Hello, in this lecture we'll find out the radius of a circle. In the drawing we have the right triangle ABC. Inside this right triangle we have this circle, and our mission is to find out the radius of this circle. In addition, we know that this is angle ABC, that is a right angle. This is line segment AS, that's equal to 1 unit in its length. This is line segment ST, that is equal to 3 units in its length. And finally, this is line segment TC, that is equal to 2 times square of 3 units in its length. I repeat again that our mission is to find out the radius of this circle. So, in the first step, we define the center of this circle. This point is O. And we define the radius of this circle, that is the radius that we are looking for in this question, as R. And we define the radius of the circle as X. Our mission is to find out the value of X, that is the radius of the circle. In the next step, we will join points O and Q together by a straight line. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of the circle, and ends at point Q, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OQ is the radius of this circle, is equal to X according to our definition. We can implement here rule 1. I'll repeat quickly on rule 1. According to rule 1, a tangent to a circle is perpendicular to the radius formed to its point of tendency. So in the drawing we have a circle, and we also have tangent AB, that is tangent to this circle at this point. Point M is the point of tendency of tangent AB with this circle. And we also have the radius OM that is equal to R. The radius OM is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. So we can actually implement rule 1 in our drawing. Why? Because in our drawing we have the radius OQ that is drawn to point Q, that is the point of tendency of tangent BC with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BC will be perpendicular to the radius QO. If BC is perpendicular to QO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. OP is the radius of this circle that is equal to X. Again, we have here the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees. and this angle also equals to 90 degrees according to rule 1. So actually in quadrilateral OPBQ we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the side of this missing fourth angle. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in its side. Again, in order to complete the sum of the angles inside this quadrilateral POQB to 360 degrees, this missing fourth angle must be equal to 90 degrees in its side. So inside quadrilateral POQB we have 4 right angles, and quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral POQB as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. So in rectangle POQB, side PO must be equal to the opposite side BQ. But PO equals to x, therefore BQ must be also equal to x because they are equal to each other. Likewise, according to the same rule, in the same triangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to x, therefore PB must be also equal to x units in its length because they are equal to each other. So actually found out that this quadrilateral POQB is not a rectangle but a square. So in the next step, we'll define the length of this line segment AP as A, and we'll define the length of this line segment QC is B, and we will implement rule 10 in the current start point, point A. I'll repeat quickly on rule 10. According to rule 10, rule 10 is true in any circle. So in any circle, if we have AB that is a chord inside this circle, and we have the common start point, point P. From the common start point, point P, if we join points P and A together by a straight line, and then if from this common start point P we draw tangent PT that is tangent to this circle here at this point T. So in this drawing, the following equation will be true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. So we can actually implement rule 10 in our drawing. Why? Because in our drawing we have the common start point, point A, and we have here chord ST, and the extended chord ST touches the common start point, point A, and for the common start point, point A, we have tangent AP that is tangent to this circle at this point, point P. So all the requirements of rule 10 are satisfied, and therefore can implement rule 10. And according to rule 10, the following equation will be true. That AP square equals to AS times AT. repeat again, according to rule 10, if you focus on the common standpoint point A, the following equation will be true, that AP squared will be equal to AS times AT. AP is A according to our definition, therefore AP squared is A squared. So A squared must be equal to AS. AS is 1 times AT. From the drawing it is very easy to see that AT in total equals to 1 plus 3. Okay. So in conclusion, I should found out that according to rule 10, A squared equals to 1 times 1 plus 3. That is to say, A squared equals to 1 times 1 plus 3 is 4, and 1 times 4 is 4. In conclusion, we actually found out that A squared equals to 4. Here we take a root out of this equation, and finally we'll get that A equals to the square root of 4, that is 2. A equals to 2 units in its length. That is to say, 97 AB is equal to A is equals to 2 units. Likewise, we'll implement rule 10 on the common standpoint point C. From the common standpoint point C, we have tangent CQ that is tangent to this circle here at point Q, and the extended chord ST touches point C, so all the requirements of rule 10 are satisfied, and therefore you can implement here rule 10. According to rule 10, we get that CQ squared equals to CT times CS. Repeat again, if you focus on the common standpoint point C, according to rule 10, the following equation is true, that CQ squared equals to CT times CS. CQ equals to B according to our definition, therefore CQ squared equals to B squared, and it is equals to CT. CT equals to 2 times square root of 3 according to what is given us in the question, times CS. CS or SC, SC equals to 3 plus 2 times square root of 3. In conclusion, I actually found out that according to rule 10, B squared equals to 2 times square root of 3 times 3 plus 2 times square root of 3. Here we'll open the brackets on this side of this equation, and finally we get that B squared equals to 2 times 3 times square root of 3 plus 2 times square root of 3 times 2 times square root of 3 equals to 12. Well, because 2 times 2 is 4, square root of 3 times square root of 3 is 3, and 3 times 4 is 12. So this expression 2 times 3 times square root of 3 plus 12 here, we substitute 12.9 plus 3 and we get that b squared equals to 12 is 9 plus 3 plus 2 times 3 times square root of 3. And this expression 9 plus 3 plus 2 times 3 times square root of 3 is equivalent to the algebraic identity that states that a squared plus b squared plus 2 times a times b equals to a plus b squared. If we just substitute a by 3 and b by square root of 3, we actually get that 9 plus 3 plus 2 times 3 times square root of 3 equals to a squared plus b squared plus 2 times ab. Well, because a equals to 3, therefore a squared is 3 squared, that is 9. B equals to the square root of 3, therefore b squared equals to the square root of 3 squared, that is 3, which is 9 plus 3, plus 2 times a, that is 3, times b, that is square root of 3. So if we found out that 9 plus 3 plus 2 times 3 times square root of 3 equals exactly to a squared plus b squared plus 2 times ab, if we substitute a by 3 and b by square root of 3. And this expression a squared plus b squared equals to a plus b squared according to this algebraic identity. And therefore this expression 9 plus 3 plus 2 times 3 times square root of 3 will be also equal to a plus b squared if we substitute a by 3 and b by square root of 3, then a plus b will be 3 plus square root of 3 squared. In conclusion, we found out that 9 plus 3 plus 2 times 3 times square root of 3 is equal to exactly 3 plus square root of 3 squared according to this algebraic identity. And those two expressions are equal to each other, and therefore this expression must be also equal to b squared. In conclusion, we found out that b squared equals to 3 plus square root of 3 squared. Well, because those two expressions, they are identical, and those two expressions are equal to each other. Therefore, those two expressions must be also equal to each other. That is to say, b squared equals to 3 plus square root of 3 squared. So here we take a look at this equation, and finally we get that b equals to 3 plus square root of 3. Square root of 3 equals to 1.732, and therefore 3 plus square root of 3 will be equal to 4.732. In conclusion, we found out that b equals to 4.732 units in its length. So this nice symmetric QC is equals to b equals to 4.732 units, and we have already found out that this nice symmetric AP is equal to a according to our definition, it is equal to 2 units. So in the next step, we will implement the Pythagoras theorem on this right big triangle, triangle ABC. Here by PT is the abbreviation for Pythagoras theorem. according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in this right big triangle ABC is AC, therefore the square of the hypotenuse is AC square, and it must be equal to AB square plus BC square. Repeat again, according to the Pythagoras theorem, in the right triangle ABC, AC square must be equal to AB square plus BC square. What is the length of the hypotenuse AC? From the drawing, it is very easy to see that AC in total equals to 1 plus 3, that is 4, plus 2 times square root of 3. Repeat again, AC in total equals to 1 plus 3, that is 4, plus 2 times square root of 3. So AC in total equals to 4 plus 2 times square root of 3, and therefore AC square will be equal to 4 plus 2 times square root of 3 square, and it is equal to AB square. From the drawing, it is very easy to see that AB equals to 2 plus x, or x plus 2, and therefore AB square equals to x plus 2 square, plus BC square. BC equals to x plus 4.732. Therefore BC square will be equal to x plus 4.732 square. In conclusion, we should find out that 4 plus 2 times root of 3 square equals to x plus 2 square plus x plus 4.732 square. And 4 plus 2 times square root of 4 plus 2 times square root of 3 square equals in total to 55.7128, and it is equals to, on the other side of the equation we have here x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square, that is equals to x square, plus 4.732 square, that is equals to 22.3918, plus 2 times x times 4.732, that is equals to 9.464x, so in this equation we have 55.7128, and it is equals to, on the other side of the equation we have here x squared plus x squared is 2x squared, and we have here 4x plus 9.464x is equals to 13.464x, and finally 4 plus 22.3918 equals to 26.3918. In conclusion, I should found out that 55.7128 equals to 2x squared plus 13.464x plus 26.3918. Here we subtract 55.7128 0.7128 from this equation, and we get that in this side of the equation we left with nothing, 0, that is to say 0. In the other side of the equation we have here 2x squared plus 13.464x, and here we have 26.3918 minus 55.7128 is equals to minus 29.321. So we have here a quadratic equation. That is to say, we have here 2x squared plus 13.464x minus 29.321 equals to 0. Repeat again, this is a quadratic equation. So we will divide this quadratic equation by 2. And we get that 2x squared over 2 is x squared plus 13.464x over 2 is 6.732x, and finally minus 29.321 over 2 is minus 14.66. That's equals to 0. So x squared plus 6.732x minus 14.66 equals to 0. This is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Another specific quadratic equation, that is to say x squared plus 6.732x minus 14.666 equals to 0. The coefficient a equals to 1, the coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. So we just have to put the values of a, b, and c for our specific quadratic equation in the general formula for the value of x. That is to say, x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. So we just put the values of a, b, and c for our specific quadratic equation. That is to say, x squared plus 6.732x minus 14.66 equals to 0. We'll put the values of a and b and c in this general formula for x in order to find out the value of x for our specific quadratic equation. The value or the values of x for our specific quadratic equation. So we'll do it now, and we get that x equals to minus b. B is 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. B is 6.732, therefore b squared is 6.732 squared. This is actually equals to 45.3198 minus 4 times AC. So it is minus 4 times A is 1, so minus 4 times 1 is minus 4, times C is minus 14.66. So in total, 4 times AC will be equal to minus 4 times minus 14.66, that is actually equals to plus 58.64 divided by 2a. A is 1, so 2a is 2 times 1, that is 2. So we actually found out that x equals to minus 6.732 plus minus the square root of 45.3198 plus 58.64 equals to 103.9598 divided by 2. So x equals to minus 6.732 plus minus, and the square root of 103.5 the square root of 103.9598 is equals to 10.196 divided by 2. So here we'll have two solutions that are possible for x. We have the negative solution that x equals to minus 6.732 minus 10.196, that is definitely a negative number, but this solution is incorrect solution. Why? Because of the fact that x, according to our definition, x is the radius of this circle, that is the radius that we are looking for. X is a radius, is a length, and the length must be a positive number. Therefore, the negative solution for x is incorrect solution, and only the positive solution for x is possible, is correct for the value of x. And the positive solution for x is x equals to minus 6.732 plus 10.196 over 2, and minus 6.732 plus 10.196 equals to 3.464 divided by 2. So actually we found out that x equals to 3.464 over 2, that is equals to 1.732. In conclusion, we actually found out that the radius of the circle is equal to x according to our definition is equal to 1.732 units in its length. Repeat again. The radius x of this circle is equal to 1.732 units in its length. In the next step, I'll summarize the lecture. In this lecture, we found out the radius of this circle. In the drawing, we have the right triangle ABC. Inside this right triangle ABC, we have this circle, and our mission is to find out the radius of this circle. In addition, we know that this is angle ABC, that is a right angle. Line segment AS equals to 1 unit in its length. Line segment ST equals to 3 units in its length. And finally, line segment TC equals to 2 times root of 3 units in its length. Again, our mission is to find out the radius of this circle. So, first of all, we define the center of this circle, this point as O, and we define the radius of this circle, that is the radius that we are looking for, as x. Then we join points O and Q together by a straight line. What is the definition of line segment OQ? Line segment OQ starts from point O, that is the center of this circle, and then at point Q, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, OQ is the radius of this circle, that is equal to x, according to our definition. We can implement here all 1. Why? Because of the fact that the radius OQ is equal to x, the radius OQ is drawn to point Q, that is the point of tendency of tangent BC with this circle. For that reason, tangent BC will be perpendicular to the radius QO. That is to say, this angle equals to 90 degrees and this angle equals to 90 degrees according to rule 1. Likewise, we join points O and P together by a straight line. OP is the radius of this circle that is equal to x according to our definition. Again, we have here the radius OP that is drawn to point P, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius PO. If AB is perpendicular to PO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. So actually, in the quadrilateral POQB, we have 1, 2, 3 right angles. And the sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total the sum of those 4 angles must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing fourth angle must be equal to 90 degrees in size. In order to complete the sum of the angles inside this quadrilateral PBQO to 360 degrees, this missing fourth angle must be equal to 90 degrees in its size. So actually found out that inside quadrilateral POQB we have 4 right angles. And any quadrilateral that has 4 right angles must be at least a rectangle if not a square. So we relate to this quadrilateral POQB is a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, in rectangle POQB, side PO must be equal to the opposite side BQ. But PO equals to x, therefore BQ must be also equal to x because they are equal to each other. Likewise, according to the same rule, in the same triangle, in the same rectangle POQB, side OQ must be equal to the opposite side PB. But OQ equals to x, therefore PB must be also equal to x because they are equal to each other. So I actually found out that inside this quadrilateral POQB, all the sides are equal to each other, therefore this quadrilateral POQB is a square. is not, it is not a rectangle but a square. In the next step, we define this line segment AP as A, and we define this line segment QC as B. Then we implemented rule 10. I'll repeat quickly on rule 10. Rule 10 is true in any circle, so in any circle, if AB is any chord in this circle, and we have the common external point P, and we join points P and A together by a straight line, and from this common external point P, we draw perpendicular PT, that is tangent PT, that is tangent to this circle at point T here. So in this drawing, the following equation will be true, that PT square equals to PA times PB. Again, PT square equals to PA times PB. We can actually implement rule 10 in our drawing. Why? Because in our drawing, we have the common external point A. From this common external point A, we have tangent AP, and we also have the extended chord TS touches this common external point A, so all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, AP square equals to AS times AT. Again, AP square equals to AS times AT. Repeat again, if we focus on the common external point A, according to rule 10, AP square equals to AS times AT. AP is A, according to our definition, therefore AP square is A square, and it is equals to AS, that is 1, times AT, that is 1 plus 3. So in conclusion, we have found out that A square equals to 1 times 1 plus 3. So A square equals to 1, and 1 plus 3 is 4. So A square equals to 1 times 4, that is 4. In conclusion, we found out that A square equals to 4. We took a root out of this equation, and finally found out that A equals to the square root of 4, that is 2. Here A equals to 2 units in its length. Likewise, we implemented rule 10 on this common external point C. We can implement a rule 10. Why? Because from this common external point C, we have tangent CQ, and we also have here the extended chord ST touches this common external point C. So all the requirements of rule 10 are satisfied, and therefore we can implement here rule 10. According to rule 10, we get that CQ square equals to CT times CS. Again, CQ square equals to CT times CS. CQ square equals to CT times CS. CQ equals to B, according to our definition, therefore CQ square is B square. CQ square is B square, and is equals to CT. CT is 2 times square root of 3 times CS. CS is 3 plus 2 times square root of 3. In conclusion, we have found out that B square equals to 2 times square root of 3 times 3 plus 2 times square root of 3. We open the brackets on this side of the equation, and finally found out that B square equals to 2 times 3 times square root of 3 plus 2 times square root of 3 times 2 times square root of 3, that is 12. So in conclusion, we found out that B square equals to 2 times 3 times square root of 3 plus 12. Here we substitute 12 by 9 plus 3. And we actually found out that B square equals to 9 plus 3 plus 2 times 3 times square root of 3. So this expression 9 plus 3 plus 2 times 3 times square root of 3 is equivalent to the algebraic identity A square plus B square plus 2 times AB this is equals to a plus b squared. If we just substitute a in this algebraic identity by 3 and b by square root of 3, we get that a squared plus b squared plus 2 times ab equals exactly to 9 plus 3 plus 2 times 3 times square root of 3. And because of the fact that a squared plus b squared plus 2 times ab equals to a plus b squared, therefore 9 plus 3 plus 2 times 3 times square root of 3 must be also equal to a plus b squared when a equals to 3 and b equals to square root of 3. That is to say, this expression 9 plus 3 plus 2 times 3 times square root of 3 must be equal to a plus b squared. That is to say, 3 plus square root of 3 squared. And because of the fact that those two expressions are equal to each other, and those two expressions are also equal to each other, it means that those two expressions must be also equal to each other. That is to say, b squared must be equal to 3 plus square root of 3 squared. And here we took out of this equation, and finally we found out that b equals to the square root of 3, b equals to 3 plus square root of 3. Square root of 3 is 1.732, therefore 3 plus square root of 3 equals to 4.732. In conclusion, we found out that b equals to 4.732. Yeah. Line segment QC is equal to b is equals to 4.732. In the next step, we implemented the Pythagoras theorem on this right big triangle ABC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, and AC square must be equal to AB square plus BC square. Okay, again, according to the Pythagoras theorem, the right triangle ABC, AC square equals to AB square plus BC square. AC, from the drawing, it's very easy to see that AC equals to 4 plus 2 times square root of 3, therefore AC square is 4 plus 2 times square root of 3 square, and it is equals to AB square. AB is x plus 2, therefore AB square is x plus 2 square, plus BC square. BC is x plus 4.732, therefore BC square is x plus 4.732 square. So in conclusion, we found out that 4 plus 2 times square root of 3 square equals to x plus 2 square plus x plus 4.732 square. So here 4 plus 2 times square root of 3 square equals to 55.7128. On the other side of the equation we have x plus 2 square. X plus 2 square equals to x square plus 2 square, that is 4, plus 2 times x times 2, that is 4x, plus x plus 4.732 square. X plus 4.732 square equals to x square, plus 4.732 square, that is 22.3918, plus 2 times x times 4.732, that equals to 9.464x. So in this side of the equation we have 55.7128. In the other side of the equation we have here x squared plus x squared, that is 2x squared. We also have here 4x plus 9.464x. In total it is equals to 13.464x. And finally we have here 4 plus 22.3918, that is 26.3918. In conclusion, I shall found out that 55.7128 equals to 2x squared plus 13.464x plus 26.3918. Here we subtracted 55.7128 from this equation, and finally found out that in this side of the equation we left with nothing, that is to say 0. On the other side of the equation we have here 2 square x plus 13.464x, and we have here 26.3918 minus 55.7128 equals to minus 29.321. In conclusion, I actually found out that 0 equals to 2x squared plus 13.464x minus 29.321. So this is a quadratic equation. We divided this quadratic equation by 2 and finally found out that here I copied the quadratic equation again, 2x squared plus 13.464x minus 29.321 equals to 0. So we divided this quadratic equation by 2 and finally found out that 2x squared over 2 is x squared, 13.464x over 2 is 6.732x, and finally minus 29.321 over 2 is minus 14.66. So in conclusion, I actually found out that x squared plus 6.732x minus 14.66 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, that is to say, x squared plus 6.732x minus 14.66 equals to 0. The coefficient a equals to 1, the coefficient b equals to 6.732, and finally the coefficient c equals to minus 14.66. Now we just have to put the values of a, b, and c in our specific quadratic equation inside this general formula for x in order to find out the value of the values of x for our specific quadratic equation. This is to say, for x squared plus 6.732x minus 14.66 equals to 0. So we did it, and we actually found out that x equals to minus b. b is 6.732, therefore minus b is minus 6.732 plus minus square root of b squared. b is 6.732, therefore b squared is 6.732 squared, that is 45.3198, minus 4 times a. a is 1, so minus 4 times 1 is minus 4 times c, that is minus 14.66. And minus 4 times minus 14.66 equals to 58.64, plus 58.64, divided by 2a. a is 1, so 2a is 2 times 1, that is 2. So in conclusion, I actually found out that x equals to minus 6.732 plus minus root of 45.3198 plus 58.64, that is actually equals to 103.9598. So inside the root we left only with 103.9598 divided by 2. And the square root of 103.9598 equals to 10.196. So in conclusion, we actually found out that x equals to minus 6.732 plus minus 10.196 over 2. So here we will have two solutions that are possible for x. The negative solution is minus 6.732 minus 10.96, that is definitely a negative number. But this solution is incorrect solution. We cancel this solution. Why? Because of the fact that x, according to our definition, is the radius of this circle, and the radius is a length, and a length must be a positive number. Therefore, the negative solution is an irrelevant solution. We cancel the solution, and we left only with the positive solution that is possible for the value of x. And the positive solution for x is x equals to minus 6.732 plus 10.196 over 2, and minus 6.732 plus 10.196 equals to 3.464. So x equals to 3.464 over 2, it is actually equals to 1.732. In conclusion, we actually found out that the radius of this circle is equal to x according to our definition, is equals to 1.732 units. Okay, thank you very much.